Hey there, folks. I'm in the greenhouse today, and yeah, you're going to hear some chickens too. The chickens are right behind me. But I thought I would make a couple videos about the project you're going to do. So the first video is going to be out here in the greenhouse, and sorry, what I usually do is I usually do a lecture about scientific method and how we do science. So I want to start out with that first, and that's kind of why I'm out in the greenhouse. Then the second video I'll do will be specifically on the project and show you exactly how to do it and how to fill out the forms and all that sort of thing. But I want to kind of start out talking about scientific method and how we do science because that's really, really important. You probably had this in middle school. You probably did this in high school. So hopefully, scientific method is something you've heard before. You may know how to do it, and that's good. But I want to kind of go over it for those of you who don't remember it as well, uh, or maybe didn't have it in school. So scientific method is the way that we do science. There's lots of, if you look it up on the internet, you'll see different ways of doing it. In other words, different steps. I'm going to show you kind of a 5-step process. And so the first step is to ask a question. And so that's what we're going to do right now. We're going to ask a question. I usually start that out with a story because I am out here in the garden and in the greenhouse specifically, but I like to grow tomatoes. That's kind of a fun thing to do because you can do so many things with them. And we make pizza sauce, I make salsa, I make tomato sauce, I make spaghetti sauce. I make, there's all kinds of cool stuff you can do with tomatoes. So I usually grow a lot of tomatoes, and they're kind of easy to grow as long as you have plenty of heat. They like 90-degree days and plenty of water. So if you got plenty of water, plenty of heat, almost anybody, and sunlight, almost anybody can grow a tomato. Now, I start out the story by talking about my neighbor because he likes to grow tomatoes too. And so we sort of have this little competition going between me and my neighbor. Some years it's who has the first tomato. Some years who has the biggest tomato. Some years it's who has the best tasting tomato. All different kinds of little things we fight about in a friendly manner. But anyway, so this year, my neighbor comes up with this great big tomato. He's got a whole bunch of big tomatoes. And so I'm a little bit jealous, right? Because I'm growing the same type of tomato he is, but mine aren't nearly that big. And we live right next to him. It's not like he's in a different state. So we live right next to each other, and so we ought to be growing about the same size tomatoes. So I'm a little bit upset about this, and so he teases me for a while, and then finally he confesses. He said, "All right, I'll tell you what I'm doing." He says, "Actually, I switched fertilizers." So he and I both used the same fertilizer for a while. We're going to call it fertilizer X. And he says, I've been using fertilizer X for a long time, and I have too. He said, but this year I saw a thing at a garden show, and they were selling fertilizer Y, and they said it was so much better. And so he said, I started using fertilizer Y this year, and guess what? I've got bigger tomatoes. So I started thinking about that and thinking, well, maybe I should start using fertilizer Y, right? And so I could start using fertilizer Y right now and see if it works. But there's a chance that he's pulling my leg, right? That he may give me fertilizer Y, or I may get fertilizer Y, and it doesn't work at all, or it doesn't work very well at all. Maybe even it kills tomatoes. Who knows? So rather than use it on my real tomatoes and run the risk of ruining a whole crop for an entire year, what I'd like to do is do an experiment. I'd like to find out in an experiment, does fertilizer Y work better than fertilizer X, right? I mean, that makes sense. So I'm ready to start. That's kind of my question, right? My question is about fertilizer Y. Is fertilizer Y better than fertilizer X? So you might write that down. So I'm going to write that down here as my question on a piece of paper. Does fertilizer Y work better than fertilizer X? Now, here's the problem. When we do a science investigation, we want to be as specific as we can. We don't want to use words like better. I mean, because what is better? Who decides what's better, right? One person's better might be another person's not so much better. So we need to be as specific as we can, and we want to make sure that when we write our question, It's got things in there that we can actually measure. How do you measure better, right? Is there a scale or something you can use to measure better? Well, there's not. So we need to refine that question. I mean, that's sort of what we're after, right? Better tomatoes. But let's be more specific. What's something we could measure about tomatoes? Well, we could measure their size, couldn't we? So, does fertilizer Y grow bigger tomatoes? Right. That was the whole point. He had bigger tomatoes. Does it grow bigger tomatoes than fertilizer X? Well, that's something we can measure, sort of, because there's lots of ways you can measure bigger, right? Do we mean bigger round circumference, right? Do we mean bigger weight, the mass of the tomato? Um, do we mean bigger diameter, right? There's lots of ways we can measure a tomato. So even saying bigger, we have to be more specific, don't we? So let's do something because we can't really measure bigger, but we could measure circumference, can't we? So the question might be, does fertilizer Y produce bigger circumference tomatoes than fertilizer X? That might be our question, because circumference is something I can measure, isn't it? I can get a little flexible tape measure or a string even, and wrap the string around the tomato and then measure the string. That would make a bigger circumference tomato. But I could do it either way, couldn't I? I could do it lots of other ways. I mean, that was the bigger question, but what if I wanted more tomatoes, right? Let's say I want to do a whole lot of spaghetti sauce. I might ask the question, does fertilizer Y produce more tomatoes than fertilizer X? Maybe I want a better tasting tomato. Now, that's a little bit harder to measure, isn't it? That's where we get into the idea of subjective and objective data. Subjective data is something that's very difficult to measure, like taste, because I may think this tomato tastes good and you might think the tomato tastes bad. That's a little bit subjective. But as long as we control it, we can use it. Objective things are like the measurement. If I measure the circumference of a tomato and I hand it to you and you measure it, we should get the same number. So that's objective data. And objective data is always better, right? But sometimes subjective data is important. So I could even go on taste if I wanted to. So even color, right? Does fertilizer Y produce a tomato that's has more red color or more yellow color? So there's lots of things we can do. So that's why your question is so important. It's going to define exactly how you're going to do your experiment. So for our experiment, we're going to say, does fertilizer Y grow tomatoes with a larger circumference than fertilizer X? Now, question mark. Now, that is a good question, but remember that's all we're looking at. Fertilizer Y on the plants, it may grow only one tomato, but it may be a giant, great big tomato, right? You've seen pictures of those watermelons, right? That they have to get the forklift and pick them up. Well, that's how they grow them. They get rid of all the other flowers, so the whole plant, all the plant's energy is going into growing one great big pumpkin. So I may get a big tomato, but that may be all I get from that plant. So it's very important that our question is very specific. Now, the second part of scientific method is what you remember from middle school, right? I asked the question. Now I'm going to answer the question with a hypothesis. Now, a hypothesis, SIS. Now, a hypothesis is answering the question, but we call it an educated guess. Now, it's not a guess. In other words, you can't just, guess. It's supposed to be an educated guess. So, what would be educated about this guess for my tomato experiment? Well, the education would be I've talked to my neighbor. My neighbor I've seen big tomatoes. Now, again, that doesn't mean I haven't answered the question scientifically yet. I've simply given a hypothesis. So, my hypothesis to the answer, does fertilizer Y grow tomatoes with a larger circumference than fertilizer X? My hypothesis might be yes. Yes, fertilizer Y does grow tomatoes with a larger circumference. Now, here's the trick. That's just a guess. Here's the educated part, I always have a because. Because. So your hypothesis should always have a because. It grows larger tomatoes because my neighbor uses it and he gets big tomatoes. That's the because, right? So that's the educated part of the guess. And it's always got to be in your hypothesis. You can't just say, yes, fertilizer Y grows bigger tomatoes. Now, could I have said no? Could my hypothesis be no? Yes, it could. I could say no. No, fertilizer Y does not grow bigger tomatoes. Now, what would be my because? Well, it might be something like, because I know my neighbor is always playing jokes on me, and I think this is just another one of his jokes. Well, that's a completely legitimate answer. Fertilizer Y doesn't grow them because I think he's pulling my leg, or maybe he went to the store and bought great big tomatoes or something. Who knows? So yeah, your hypothesis could be yes, it could be no, so it can be whatever, but there has to be the because there. There has to be a reason, there has to be an educated guess as to why that is. All right, great. So now we have our question on hypothesis. Now what we're ready for is the experiment. Now we're going to do our experiment. Now, this is really the trickiest part. This is really can be the most difficult part because when we're setting up our experiment, we've got all these variables, right? Let's say I'm going to grow some tomatoes, right? Obviously, because I'm going to test my different fertilizers. But I got all kinds of variables, don't I? Well, the fertilizer obviously is a variable because that's what I'm testing. But what about the amount of water, right? What about the amount of sunlight? What about the type of soil? What about the size of the container, right? What about? I mean, there's just hundreds of them, right? Different variables that could affect my tomatoes, right? What about the temperature? So there's all kinds of things that could affect my tomatoes. So what I want to do when I set up my experiment is I want to make sure that all my tomatoes are getting exactly the same thing. And the only thing I'm changing with one group, right, is the fertilizer. So it sounds to me like what we should do is go plant two groups of tomatoes. Should we plant, let's go out in the garden and find a spot. Should we plant our tomatoes, should we plant two tomato plants for each group? So two tomato plants for fertilizer X, two tomato plants going to get fertilizer Y. Would that work well? Yeah, it might. But would three plants be better? Would four plants be better? Because one of those plants might, sometimes you plant a tomato in the garden and just for some reason it just dies. I mean, it's right next to all the other tomato plants. They're doing great, and this one just doesn't. So, I mean, sometimes they do that. So, yeah, four would be better, wouldn't it? Six, would that be better than four? Yep. 12 would be better than six. How about 100? You can see where we're going, right? Yeah. So the more you can do, right, the better your data is going to be, right? Because you're going to get a lot of information from 100 plants, a lot more information from 100 plants than you would from two. So, but there's a limit, right? I mean, maybe if you're a college or something or a scientific group, you can plant thousands of tomato plants. And if you say you sell fertilizer Y or you sell tomatoes, you may grow hundreds of tomato plants, right, to test your theory. But let's say for ours, let's say I'm going to grow a dozen, right? So now we got to think about, well, is growing them out in the garden a good thing? Because out in the garden, there may be different kinds of soils. I mean, maybe this soil over here got a little bit too much sand in it one year, or maybe this one over here's got a lot of weeds in it for 1 year. So maybe actually growing them in the garden is not a good thing. I need to control that. So maybe I grow them in the greenhouse, right? Maybe we grow them in the greenhouse. That way we can control the soil, can't we? We can control the water because we don't have to worry about the rain. We can control exactly the amount of water. We control the temperature because I've got a fan in the greenhouse. I can open the door and cool off the temperature, or I can close the fan on the door and warm it up in here. There's plenty of sunlight coming in, and they'll all get exactly the same sunlight. So maybe growing them in the greenhouse, what we call a controlled environment, is better because I can control everything. Out there in the garden, I don't have as much control. But in here, I've got a lot more control. Now, one thing we do have to remember, though, is if we grow them in the greenhouse, don't forget about pollination, right? Because every one of those little flowers that comes out is going to turn into a tomato, maybe, as long as it gets pollinated. So we may have to either pollinate them ourselves, or we may have to bring in some bees. And I just happen to have a nice nest of bees up here, so you may see me swatting every now and then. So anything grown in here, we get plenty of pollination. But that's the other thing. So really, when you're setting up your experiment, you got to think of all these factors, all these variables. I got to keep everything exactly the same. The water exactly the same. The size of the pot exactly the same. A number of plants per group exactly the same. Everything exactly the same. But I change one thing, don't I? I change one thing and one thing only, and that is the fertilizer. Does that make sense? Because let's say I do change the fertilizer, but I don't water them the same, right? And I get big tomatoes out of one of them. Well, what made the big tomatoes? Was it the fertilizer or the water? We don't know, because I changed two things at the same time. So it's important to make sure everything's exactly the same. So if there is a change between the two groups, there's only one thing that could have made that change. And for us in here, it's going to be the fertilizer. So let's set up our experiment. Here we go. So I've got a container here. There we go. There's our first container. And here's another container. I don't know if you can see that or not. Hopefully you can. There's another container right there. So I'll label these fertilizer X and fertilizer Y, right? And then we said we want to keep our containers, our actual things for the plants, exactly the same. So I'm going to use, everything is going to be using these cups. So every single thing, all the tomatoes will grow. Let me see if I can get that. There you go. Now you can see it. Will grow in these cups. And so if I do 12 on this side, right, I got to do 12 on this side. When I fill them up with soil, I got to use exactly the same soil. I may go to the store and buy one big bag of soil. It's all exactly the same, and use that same bag for both groups. That would keep my soil the same. Maybe with watering, I water them every single day at 9 o'clock. I give this side, and you're writing all this stuff down, right? Because this is your procedure, and you're going to have to explain that. Explain your procedure. Step 1, step 2, step 3. So I'm writing all that stuff down. Get 2 trays. Get 12 cups for each tray. Get 1 bag of soil. Add soil. You know, you're writing all this down. This is your procedure, because if I come up with a solution, if I come up with fertilizer Y does grow bigger tomatoes, someone else out there may say, well, I don't believe that. I'm going to copy your experiment. We call that peer review. And if you're in business, right, some of you business people know that if you do something, you kind of keep it a secret, don't you? You don't want everyone else to know. But in science, we do it exactly the opposite. If you learn something incredible, if you learn something new, you want everybody to know, right? Because they're going to go out and copy what you did, right, through a peer review process. You're going to print this up in a magazine. They're going to go out and copy what you did. If they get the same results as you, then you were right, right? But if you don't tell people, then people can't believe you. I mean, if I can't copy your experiment and get the same results, then that's not science, right? So we want everybody to know what we did. We want to make sure our procedure is so complete that I could literally take your procedure and redo your experiment exactly. So you've got to have everything there, right? So anyway, so we'll fill these up with whatever we're going to do. And then we get some seeds, some tomato seeds, right? Do I use 2 different varieties? No. I'm going to use the same variety. Here's some, I brought some tomatoes in so you could see some different kinds of tomatoes. There's a tomato that you probably think of as, that looks like a tomato. Here are some, I grew some French tomatoes this year. So here's some little French tomatoes that are very good. This is a sauce tomato called San Marziano. And then some of the tomatoes even are different colors. So there's a yellow one, or no, I guess that's an orange one. I've got some yellow ones out there. I've even got some ones that are green and striped. So they could have different colors. I've even got this French one here, which is kind of cool. It's all knobby. Isn't that well? So that looks like a bunch of grapes, but in fact, that's one tomato. And again, it's a French variety. It's called the traveling tomato, because what you can do is if you are traveling on a trip, you can break off these little pieces, like that one right there. You can break them off just like that and eat them. They're very good. So this is the first year I've grown that. It's kind of cool. But So we're going to have to pick a variety of tomato. And since we're measuring circumference, a tomato like this would be kind of hard to measure, wouldn't it? So I wouldn't want to grow this variety. But I might want to grow this variety, although the roundness of it's not so great. I might even think, well, this would be better because it's a round tomato. It'd be easy to measure. So that's what I might do. Now, if I were doing mass, if we're doing weight, then yeah, one of these tomatoes might be good because they do get kind of big anyway, and so I'll be able to measure them pretty easy. These tomatoes here would be difficult to do with weight, even though they have weight. But when they grow, they're all almost exactly the same size, so it'd be kind of hard to average those together. But again, that's entirely up to you. It's your experiment, right? So we're ready to go, right? I've got my two groups, fertilizer X, fertilizer Y. I've got all my things ready to go. Everything's going. Have I forgotten something? And again, this is hard to do because usually I ask you guys directly. And someone might remember that, in fact, yeah, there is something you could do, couldn't you? I could add a third tray, right? And 12 more plants, couldn't I? But you say, wait a minute, but I'm only comparing two fertilizers, X and Y. What would go in this one, right? What fertilizer would I put in this one? Would I mix the two together? No, that's not a good idea. The fertilizer that would go in this one is no fertilizer, right? This is what we call our control. This is our control group. Now, why would I have a control group? Why would I have a group of tomatoes with no fertilizer? Well, let's say this is expensive fertilizer, right? It cost me $100 to buy a bag of this fertilizer. And if I grow a bunch of tomatoes with no fertilizer and they grow just as big as those, why am I wasting $100 for fertilizer, right? So yeah, our control group always shows us what the thing we're testing actually does. See what I'm saying? So again, I'm sweating in my greenhouse. It's kind of warm in here. So a control group would be a good thing, wouldn't it? So now we're ready to go, right? We've got my three groups. I'm ready to plant all my tomatoes, water them, and then now they're starting to come up. And so what I may do, I'm starting to collect data. So I need a database. So I need to set up a data thing so I can collect data. So I will have three columns for my three groups. There's fertilizer X, there's fertilizer Y group, and there's my control group, C. And if I've got 12 tomatoes, then I'm going to be collecting data on 12 plants, right? Well, maybe, but remember, each plant is going to produce more than one tomato. So maybe plant one has 5 spaces for 5 different tomatoes, maybe 10, who knows? It depends on how much data you want to collect. But every single tomato that you measure, you want to kind of give it a number. So this might be, let's say this is X, then this plant here might be X1. So that plant is X1. This plant might be X2. This plant might be Y1. See? So I can keep track of them. And then as they make tomatoes, excuse me, the tomato's starting to kick back. It's got a lot of acid in it. So as I start collecting tomatoes, maybe the first tomato that I pick and measure would be tomato X1-1, something like that. So I can keep track of all my data. And so my data would be here with the number of tomato, and the numbers would be inches or centimeters, probably. In science, we use centimeters. So this might be in centimeters. So tomato 1 might have been a circumference of 5.6 centimeters. Tomato 2 from plant X1 might have been 6.8 centimeters, right? And I just brought a little baby tomato plant so you can kind of see. And this is not baby, these are actually miniature tomato plants. So there they are growing, right? And I could actually wait for them to turn. The other thing is you'd have to decide, how do I measure a green one, or do I wait until they're fully ripe? Make sure that's in your procedure. But this might be how they grow, right? And you might grow this. Again, this is a miniature variety. This is as big as it gets. I've got tomatoes out there that are about 10 feet tall. So tomato plants can grow pretty big if you let them. So we're collecting our data, aren't we? And we got to be very, very clear about how we do that with our data. Now, after we've collected data, which is the which is the third experiment and data, third part of our experiment, then finally we want to do an analysis, right? We've got all of our data, everything's filled in. We've done all of our, and boy, it's really getting hot in here. I'm going to have to turn the fan on high. Sorry. So we've got all of our data collected. Now we're ready to do an analysis. How do we do an analysis? Well, the best way to do that is with a graph, right? So we could do that several ways, couldn't we? One of the ways we could do that might be, let me pause this. Hang on, guys. Sorry, guys. Sorry about that. So we were talking about procedure, and we were talking about getting ready to do analysis, right? So when we do our analysis, we want to do it using some kind of a graph. So what we might do here is we might do a graph, and you could do this lots of ways. You could do, well, you're obviously going to have, it's probably going to be like a bar graph, right? And you're going to have 3 bars for the 3 different groups. You're going to have an X bar, a Y bar, and a control bar. Then over here on the side, obviously you're going to have circumferences, right? You're going to have, these are going to be in centimeters. So make sure you write that in centimeters, the numbers. Now, what you could do is and you'll do this in the title, you could say maybe you average all the tomatoes, right? Maybe you took all the tomatoes that grew on the X plants, right? Averaged them together and got a number, and that was what that bar would be. Maybe you used a cumulative. Maybe you just literally added up all the sizes of tomatoes, right? And put that in the X side. So you can do it however you want. But this would probably be a bar graph. And it would show then, on average, right, you might have more tomatoes, more larger tomatoes with X than Y, or Y than X, whatever. But this is what's going to help you answer your question, right? Now, remember, when you use an average, you may say the average tomatoes were the largest tomatoes in Y, right? The average tomato was the largest, but you may have the biggest tomato you ever grew might have grown from X. That might make you start to think, well, I wonder, because your question might have been, which fertilizer grows the one largest? That would change this entirely, wouldn't it? It wouldn't be Y, it would be X. You wouldn't use an average. You'd just simply look for the biggest tomato. So again, you can see how this all goes back to question. Finally, so this is our analysis. Finally, the 5th stage, right, is our conclusion, right? And so what we're going to do is, in the conclusion, we answer the question. Because now we know, don't we? We don't have to guess. We don't need an educated guess. Now we know, based on our data, which it is. So in our conclusion, we write that out, that fertilizer Y, maybe fertilizer Y was the biggest, right? Fertilizer Y does grow, on average, the largest tomatoes, then larger tomatoes, then fertilizer X. You might even make a note about control. Maybe the control actually grew tomatoes bigger than X, but not as big as Y. So in your conclusion, you talk about all those different things, right? And so that's how we answer a question. That's how we would answer a question scientifically. Does that make sense? That's scientific method. And that's pretty much what you're going to do for your project. I'm going to have like some forms and stuff that you can fill out, so you don't have to kind of go through all this on your own. But essentially, we're going to be doing exactly that same thing. So if you got questions, let me know. Like I said, I'll put this in a separate thing so we can kind of have a discussion if you're not sure about it. But everyone's going to do a project, and I'll be more clear about that when I talk about the project itself. Y'all have a great day. And I just have to turn this off.